Hello and welcome back. Today I like to show you and talk about a little bit about my lab reference. I made some videos about GPSDO. I made already a video about the distribution amplifier, the FDIS5, and this little trigger distribution amplifiers. And well, it's a lazy Saturday, and I just did the things in the lab. If you saw my other video, and I have a lot of frequency counters. I'm crazy about frequency counters. So everything is connected to the lab reference, and I just like to show you how everything is connected. And also, I have two signals that I need to distribute. It's the 10 megahertz for all the fairly new equipment, but I have also very old equipment, like the Maconis. And the Maconis, instead of 10 megahertz, they need 1 megahertz. And well, I don't want to have too many different distribution amplifiers. Uh, so all the distribution amplifiers or trigger amplifiers that it actually are, um, I want to use for 10 megahertz and 10 megahertz only, because otherwise I'm gonna pick the wrong amplifier and then, well, it doesn't work. So, but there is a trick, and I'm gonna show you how to distribute over 1 megahertz. Well, to start at the beginning, here is my GPSDO, and what it is, it's a GPS receiver, and it's a disciplined oscillator. So this oscillator is set to 10 megahertz, and the GPS and all the GPSs are connected to the atomic clock, so the timing there is very, very precise. So this disciplined oscillator is disciplined by the atomic clock. So that's why, well, you can see it is really 10 megahertz. Now it's even, the reception is very, very good right now. So it's really 10,000.000.000. So even below the hertzes, there are 4 zeros. So it is really properly locked in. But it only has one output. And as I mentioned before, I have a little bit more than one device. So that's why I have this. This is my first distribution amplifier. This one also has a frequency standard. So when the GPSDO fails for whatever reason, maybe my cable is broken because the satellites are probably going to stay for a while. It also has an internal oscillator, which is also very precise. This is a special distribution amplifier, and let me zoom in on that. Okay, here it is. This is a special one. This is the FDIS5, and instead of just distributing the 10 megahertz, it's actually regenerating it. The GPSDO is a square wave, and this one just filters it to a sine, but it really regenerates itself. So, and that's why it's also possible to have multiple outputs. So here we have the normal 10 megahertz output. We have that twice. Here we have 5 megahertz. I have no use for the 5, but I have it. Here I have the 1 megahertz, also twice. One is already connected, as you can see. That goes to my Marconi, the 2955, the radio test set. And I also have a 100K right here. The 10 megahertz goes to this one goes to my other distribution amplifier. And that is just a regular. So if we zoom back out, then we have here below the other distribution amplifier. Here it is, with on top my PLL. So here the signal comes in the bottom is the input, and here we have 8 outputs. And as you can see, this one is already full, and that's why I was thinking of adding an extra one. And let's have a closer look to these distribution amplifiers. So here we have one. They are very popular. As you see, it says square wave distribution amplifier, and this distributes a 50 ohms impedance signal. This one you also have in 2 versions, one that has also an internal oscillator of 10 megahertz, But this is the cheaper model. Also, you can see it has BNCs, but you can also have them with SMA. And this one just simply amplifies or distributes with the correct impedance from what you put in here, and it starts just above DC up to 200 megahertz. I even think it goes up to 200, but I will be using it just for 10 megahertz. And so from the GPSDO, it goes to the FDIS5, then it goes in here, and then I can distribute to my devices. There is only one thing: these are, of course, mass produced, and there is always a little problem with them, and they all have it. And you need to open it, and then you just need to solder it, because here, and all the models have that, they use very little solder, as you can see. So it's almost open. So after a while, maybe it heats and it cools down, that will break. So that you always need to solder. So really, if you have one, open it, check it. I have 3 of these, and they all had it. Okay, that's fixed. That looks a lot better. Properly solder. And then we have something else, and that is here on the top. I have another distribution amplifier. Let's see if I can zoom a little bit. There on top, but it is a bit impractical because all the connections are in the back, and yeah, I just put the distribution amplifier this way because here I have the indication lights to see if the signal, the input signal is good, or if there is an alarm. So what I'm gonna do, of course, I'm gonna turn this backwards, but I just need to make lights on the front. Okay, here we have the amplifier, and what I mean with the lights, and as you can see, there is nothing here. So here is just the plate. Now, but of course, I will be using it like this in the back because yeah, the wires are all in the back. So I need here indication, and there are 3 LEDs here, but I think 2 is enough because here we have the power and we have the alarm, and the red is the alarm. And the alarm is now on because it doesn't see an input signal. So, but if we put input, then alarm goes off and the external in goes on. So I was thinking, instead of using the power light, I just use the external in light and the alarm light, because it is clearly, it is on now without seeing the power light, you know? Because there is a green light. And if I pull this out, after a while, it will recognize there is no signal, and then there is an alarm. So if I have these 2 lights, there cannot be a light if there is no power. So that automatically means it is switched on. Now, let's do that. I drill 2 holes to have indication on the back. That's done. It's just putting the LEDs in parallel. It will take a little bit more current, but these are these low current LEDs, 3 millimeters, all kinds of colors. And just you buy this really a bag for $1 or $2. So I have a few of those. I just put it in parallel, and at least now we have some indication. Now, so when I put here, and the cables are all in the back, I still know what's going on. Because if I put the power, well, surprise, surprise, And you see there is power and there is alarm. And the alarm is because there is no input. So we put input signal, tube, done. So we know exactly what's going on with the amplifier. Perfect. So that took a while. It's 5 minutes of video, but you know how it is here. It's just an hour has passed very quickly. So I rewired a little bit. So as you can see, I've tried to zoom in here. I have now a lot more connections left. These four I can use again. I rewired those to the other amplifier that is now right there. Here. And I think it was this and this device that I switched over here, and of course the Siglant also. They are all connected now to that one, as you could see in the picture. And keep an eye on the light here. This light here. If I take it out from the main amplifier, the alarm goes. So now we know, okay, something is wrong. So if we put it back, it will switch off and it will go back to normal. Okay, that is this one. I still have the other one up there. So I've opened the other one. This looks now a lot better. And here is the other one. Look, the first one is here. And as I mentioned, every one has it look same bed soldering. So again, we're gonna fix that. And then I'm not going to even film it, but I will put the LEDs also in this one. And then we continue with the 1 megahertz to the old Marconis that are also there. Okay, also number 2 is done. In the error, and if we put signal, it switches off. So we can put this now in the rack. Okay, there it is. That looks a lot better. Look at that, it is in sync. And now my cables also in the back are organized a lot better. Now this is going to be a little bit shaky. I don't have a stand here because I do not have enough space, but this is the back of the rack. And here you can see all the 10 megahertz cables. It all goes to the frequency counters right here. Here is one, there is one, there is one. And we have 2 other ones here. These are the 1 megahertz, and I'm gonna draw something up for it. First, let's do a little test. As you can see in the top there, it is green. Here we have one that is green in the middle right there. And here everything is green. So, and in the PLL here the 2 lights are also not blinking. They are steady. Here is also no red light. And if I go to the top, that one is also good. So let's see what happens if I take out the cable. Yes, there is the alarm. And if we go to the PLLs here, it is blinking and it's missing an input. Here is the alarm. Sorry, it's really shaky making my work. Here is the alarm, and I bet here is also the alarm. Yes. Okay, let me put it back. green, green, and green, and green, and green. It's all good. As you might have remembered from the beginning of the video, I explained I have only two outputs for 1 megahertz, but I actually need to because the Marconi right here needs 1 megahertz. And the two Marconis up here also. So I need actually 3 exits, but I don't have that. So what I'm going to do, and that has to do with impedance, all the 50 ohm devices with the 10 megahertz are all 50 ohms and they are terminated inside the device. So let's say the cyclant right here. In the back, it has an external reference. It is connected to it, but internally it's terminated with 50 ohms. So I need a direct connection. So that means if I have here distribution amplifier, also built for 50 ohms, I connect that with the BNC cable to the cyclant. Also 50 ohms, perfect. These ones I cannot put in parallel. If I have another device here, I need to do like this. I cannot do like this because then this impedance becomes roughly 25. No, not 50 ohms anymore because you have 50-50 in parallel. So we're not going to do this, you do this. So the correct way would be this. But with the 1 megahertz is a different story because the 1 megahertz is those inputs of the Marconis are actually 1 mega ohm and not 50 ohms. So those you need to terminate because the distribution amplifier is 50 ohms and the Marconi is 1 mega. So how does that work? So this is my, because I don't want, what I can do is have a 1 megahertz distribution amplifier. Then I need another one. But I only have 3 devices and I have not too many devices that use 1 megahertz. So that is silly. So what I'm going to do, I have 2 exits for 1. So the Marconi, I will just connect like this. But I need, this is 50 ohms, this is 1 mega ohm. It doesn't connect well, so you need a terminator. And there, why you have these, you just put the T connector, 50 ohms in the other side. So I put here a T, put my 50 ohms here. 50 ohms parallel and 1 mega ohm is still 50 ohms, so that is perfect. So I have my 50 ohms here, and also this device is close to my GPSDO, and these devices are close together. And so what I want to do, I have here one long cable. I will do like this because it's a long cable, and I connect here. Here is still 50 ohms. Here I have 1 mega ohm. And here I have also 1 mega ohm. I can put these two in parallel because the mega ohm parallel with the mega ohm is still a lot more than the 50, so there is no problem. So what I do, I will put the T here, T connection here, put my cable to this one, and then let's say roughly you have 500 Ks. Now that is still not good because this is 50 ohm. Then you just put your terminator here. I make this one also 50 ohms. And then I can probably do this with 1 because these are such high impedances, it will not notice that they are in parallel. Because if you have your 50 ohms with those two in parallel, which are 1 mega is 500K, parallel on 50, it's still like 59 and a very little bit. So that is perfect. So that's what I'm going to do. Then I also need only 1 cable here. And I have enough of these T connectors, BNC, and this little, you can see 50 ohm terminators. Okay, this is going to be a little bit shaky, but we are on the back here. Here is my 1 megahertz in. It was a bit long, so I made a circle, but then it comes here through the T. Again here with a little cable, again a T and a little terminator. Okay, here we have a look. So as you know, I have two cables to the back of this side of my lab, and that is one is the 10 megahertz, which goes through the distribution amplifier, and one megahertz. The 1 megahertz is now connected to the external reference of both of them. So let's see if we measure 10, it should be exactly 10. So well, I would say that is exactly 10. And what does this one say? Nope. But the last digit is always tricky. Look at that. And even if we do this, it will do also 10, but then again, the last digit. Here it is. Look at this. Perfect. So that works. So now I am just testing if everything is good. The I have here the Siglant that is pushing out a signal of 5 megahertz, and it is connected to the external reference, the box on top, and that signal I read with the frequency counter right here. That is connected to the other distribution amplifier, but it is all synced. As you can see, this is a perfect 5 megahertz. Again, it's always that last digit, but that is normal. So I'm satisfied with the result. So that's it. A lot of reference, a lot of distribution amplifiers. I hope you enjoyed it, but it was just something that I wanted to do because I wasn't happy how it was working now. And the 1 megahertz I really needed to do to the other counters. So now everything is connected to the reference. Good result. Thank you for watching, and I hope to see you next time.